When the First World War erupted in 1914, the industrial world was about to learn what true mechanized warfare meant. The old doctrines, cavalry charges, bayonets, and glory in open fields, died under the unrelenting fire of machine guns. Across Europe, entire divisions were cut down in minutes. The German MGs-08, the British Vickers, and the French Hotchkiss poured out bullets in mechanical torrents that turned landscapes into wastelands. The machine gun had become not just a weapon, it was a symbol of industrialized death. And the United States, still neutral at the time, was unprepared for what was coming. By 1916, when the U.S. military began preparing for eventual involvement, their arsenal was painfully outdated. Their standard infantry arm was the Springfield M1903, a bolt-action rifle, accurate but slow. For automatic fire, America relied heavily on foreign designs, Colt-licensed Vickers guns, the Benet Mercier, and a handful of Lewis guns. But these weapons were unreliable in mud, complicated to maintain, and required constant lubrication and cleaning under combat conditions. European soldiers had already learned this the hard way in the trenches of the Somme and Verdun. Rain, dirt, and corrosion would seize a gun's moving parts, and when that happened, men died. The U.S. Ordnance Department knew it needed something different, a gun built not for laboratory precision, but for war itself. It had to be simple enough for a soldier to field strip under fire, durable enough to withstand months in mud, and powerful enough to stop aircraft and vehicles as the battlefield evolved. By late 1916, the future of warfare was changing again. The first tanks appeared on the Western Front, slow, armored beasts that shrugged off rifle bullets. At the same time, airplanes had transitioned from reconnaissance to deadly dogfights and strafing runs. The military needed a weapon that could punch through armor and still function with the brutal reliability of an infantry gun. The current .30 caliber rounds weren't enough. Something bigger was needed, something that could tear through metal. The Army's ballistics section began discussing a heavy caliber machine gun capable of firing rounds over half an inch in diameter. The specification was ambitious, a bullet weighing nearly 700 grains, traveling at over 2,700 feet per second, and capable of destroying both aircraft and lightly armored targets. No such weapon existed in the American arsenal, or anywhere in the world, with the kind of endurance they demanded. At the time, America's top gunmaker, Colt, was struggling to meet wartime contracts. But there was one man who had never failed the U.S. Army, a man who had already revolutionized firearms with designs that worked every single time: John Moses Browning. By this point, Browning was already a legend. He had designed some of the most influential weapons in history: the Colt M1911 pistol, the Winchester lever-action rifles, and the automatic rifle that would become the bar. His inventions weren't just brilliant, they were practical. Every soldier who used them could feel that they were built by someone who understood what a gun must do when everything else fails. Browning's reputation wasn't built in boardrooms or laboratories, and it was forged in the field. He believed a firearm should be as close to foolproof as humanly possible. His designs had fewer moving parts, cleaner lines, and stronger tolerances than any of his contemporaries. He once said that complexity is the enemy of reliability. That philosophy guided every weapon he ever built. So when the U.S. Army came calling for a gun that could fire a new .50 caliber round, Browning didn't hesitate. He accepted the challenge, not as a manufacturer, but as a man determined to solve a problem others thought impossible. He began by examining what already existed: the Browning M1917, his earlier water-cooled machine gun that had already proven itself superior to the British Vickers in reliability and ease of use. If he could scale that design up, perhaps he could create a heavier, faster, and more lethal version capable of firing the massive new cartridge. But this wouldn't be a simple task of enlarging parts. Everything would have to be rebalanced: the bolt, barrel, recoil springs, and feed system, to handle the tremendous pressures of the .50 BMG. The recoil would be violent. The heat would be destructive, and the speed of operation would test the limits of metal itself. Still, Browning worked quietly and methodically, often spending nights in his workshop testing small mechanisms by hand. He didn't have the luxury of modern materials or high-speed computation. All he had was experience and an instinct for mechanical truth. And as 1917 approached, that instinct was about to meet America's need for innovation. Because soon the war would no longer be across the ocean. It would call for American firepower, and the man who could provide it was already waiting, blueprint in hand. John Moses Browning's life had been defined by invention from the very beginning. Born in 1855 in Ogden, Utah, he grew up in a family of gunsmiths, learning to carve, shape, and assemble firearms before most children had learned to write. By the age of 20, he had already patented several rifle and shotgun designs, and by 30 he was working closely with Colt and Winchester, shaping the trajectory of American small arms. Browning was a quiet man, rarely seeking fame, yet his influence on modern warfare was profound. His designs were never just mechanical. They were solutions to human problems. He understood the battlefield as a place of chaos, mud, and human error, and he built weapons that could survive those conditions. Simplicity, durability, and reliability were his guiding principles. By 1917, the U.S. Army had a specific problem. They needed a heavy machine gun capable of long-range, high-caliber fire. European armies had already experimented with anti-aircraft and anti-vehicle rounds, but American designers had not yet produced a weapon capable of handling the required .50 caliber round. It was a massive challenge. Browning approached it like any other problem, systematically. He began by examining the limitations of his existing M1917 water-cooled machine gun. The M1917 was reliable, but its weight and water cooling system made it impractical for mobile operations. Browning knew the solution lay in a recoil-operated, air-cooled system, which would reduce weight without sacrificing firepower or reliability. But creating such a system required more than intuition. It required pushing metallurgy and engineering to their limits. The new .50 caliber cartridge was far more powerful than any round he had previously designed for. Bolts had to withstand immense pressure, barrels had to resist rapid heating, and every moving part had to function flawlessly under extreme stress. Even a minor miscalculation could render the weapon unusable or lethal to the operator. Browning worked closely with Colt manufacturing engineers, but he retained ultimate control over the design. He sketched, adjusted, and recalculated, often working late into the night. He experimented with feed mechanisms that could handle the massive rounds, testing belts, linkages, and the timing of the firing cycle with meticulous precision. The U.S. Army watched closely. They knew Browning had already revolutionized their infantry, but this was something new. A weapon designed not just to fight other soldiers, but to dominate the evolving battlefield. It would be mounted on trucks, aircraft, and tanks. It would engage targets at distances previously unimaginable for a machine gun, and yet, Browning insisted on a design that could be disassembled and reassembled by a single soldier, without special tools. This insistence on practicality was characteristic of Browning. Unlike many inventors who sought complexity or flair, he focused on what actually worked. Every spring, lever, and bolt had to have a purpose. Every design choice had to survive field conditions: mud, sand, rain, and extreme temperatures. By mid-1917, Browning's workshop had become a laboratory of innovation. Prototypes were built, tested, and rebuilt. Metal was hammered, machined, and heat-treated. Each iteration was an improvement on the last, gradually moving closer to a machine that could fire the enormous .50 caliber round safely, quickly, and reliably. Outside the workshop, the world was changing rapidly. America entered the war in April 1917, sending troops to Europe who would face modern industrialized combat. The Army needed weapons that could match and exceed the capabilities of the European powers. Browning's work was no longer just an experiment. It was essential. The lives of soldiers, the success of campaigns, and the credibility of American industry depended on it. By the end of 1917, Browning had completed a working prototype of what would become the M2 Browning machine gun. It was an engineering marvel, recoil-operated, air-cooled, belt-fed, and capable of sustained fire unlike any other American weapon of the time. The Army's officials were astonished. What had seemed impossible, a civilian designing the heaviest, fastest, most reliable machine gun in history, was now a reality. And with the world at war, The question was no longer whether it would be used, but how it would change the battlefield forever. The genius of John Browning lay in his ability to see beyond conventional engineering limits. While European machine guns relied on water cooling, complex gear systems, or fragile parts, Browning envisioned a weapon simpler, faster, and stronger. The M2 would use recoil operation, the barrel and bolt moving together to absorb energy, cycling the next round automatically. This mechanism allowed for a high rate of fire, approximately 450-600 rounds per minute, without sacrificing reliability. Unlike the Maxim or Vickers, it did not require a cumbersome water jacket, making it air-cooled and lighter. Browning also revolutionized the feeding system. He designed a belt-fed mechanism capable of continuous fire with minimal jams, a critical improvement over clip-fed designs. Every part was designed to withstand the enormous stress of the 50 BMG round, a projectile nearly twice the diameter and several times the mass of standard infantry ammunition. The gun's barrel was thick and durable, designed to resist warping from rapid fire. Its simplicity meant fewer moving parts, fewer points of failure, and unprecedented longevity. By combining these innovations, Browning had created a weapon that was not only powerful, but practical for the chaos of war. The M2's design was so advanced that it would remain largely unchanged for a century, proving the timelessness of Browning's engineering insight. Browning himself was as much a part of the weapon as the metal and springs he shaped. Quiet, disciplined, and obsessive, he was the kind of man who could spend weeks testing a single component, listening to the sound of the mechanism, feeling its resistance, imagining how a soldier in mud or rain would handle it. Unlike many inventors, Browning had a profound empathy for the men who would use his creations. He understood fear, fatigue, and confusion on the battlefield. Every design decision, from bolt tension to trigger pull, reflected this understanding. He once remarked that a soldier should be able to disassemble his gun blindfolded if necessary, a testament to his focus on usability under pressure. Even in his later years, Browning continued to tinker. He would rise before dawn, walk through his workshop, and inspect prototypes with the precision of a surgeon. For him, invention was not an abstract exercise. It was a responsibility, a promise to the men who would depend on his guns in the mud, in the trenches, and in the skies. His human touch ensured that the M2 was not merely a weapon of death, but a tool soldiers could trust with their lives. Creating the M2 was only half the battle. Manufacturing it at scale was another challenge entirely. Colt Manufacturing, Browning's partner, had experience producing the M1911 pistol and other firearms, but the M2's tolerance demands were extraordinary. Every bolt had to be perfectly machined, every spring tempered to exact specifications. The 50 caliber rounds themselves were massive, requiring precise coordination between the ammunition factories and the gun's design tolerances. Production delays, material shortages, and the enormous size of the weapon threatened to derail deployment. Browning worked closely with Colt engineers to streamline assembly, eliminate unnecessary steps, and ensure each gun could withstand repeated firing tests before leaving the factory. By solving these industrial challenges, Browning ensured the M2 would not remain an experimental marvel. It became a weapon that could be produced, shipped, and deployed reliably, an essential factor as America entered the global conflict. The M2 Browning did not just fire bullets, it reshaped the battlefield. Its 50 caliber rounds could pierce light armor, destroy vehicles, and cut down advancing infantry with terrifying efficiency. Mounted on trucks, tanks, or aircraft, it became a force multiplier, turning a single squad into a mobile fortress of firepower. In aerial warfare, the M2 proved decisive. Browning's gun could be synchronized with aircraft propellers or mounted in flexible positions, allowing fighters and bombers alike to dominate the skies. The sheer volume and range of fire allowed Allied forces to suppress enemy positions before ground troops arrived. A single gunner could hold off dozens of enemy soldiers, fundamentally changing small unit tactics. On the ground, infantry units could establish perimeter defense points with unprecedented efficiency. The M2's ability to maintain sustained fire while remaining reliable gave soldiers confidence in situations that would have been previously untenable. This adaptability across land, air, and sea made it one of the most versatile weapons in modern history. The M2 Browning was more than a physical threat. It was a psychological weapon. Its deep, thunderous report echoed across the battlefield, signaling unstoppable firepower. Enemies learned quickly that advancing under its fire meant almost certain death. For American and Allied soldiers, it provided reassurance in the chaos of combat. Knowing that one gunner could cover a wide field of fire allowed squads to maneuver with greater confidence. The M2 became a silent partner, a guardian watching over troops as they advanced. Reports from World War II recount soldiers halting under its fire, pinned by invisible waves of lead. The fear it inspired was not just in its bullets, but in the certainty of its presence. Browning's creation, though mechanical, had an almost human aura, an embodiment of unstoppable determination. The true measure of Browning's invention lies not in a single battle or war, but in its longevity. The M2 has been in continuous service for over a century, from World War I testing through World War II, Korea, Vietnam, and even modern conflicts in the Middle East. Few weapons have survived this long without fundamental redesign. Part of its enduring legacy is simplicity. Every component was designed for durability, reliability, and ease of maintenance. This allowed generations of soldiers to trust the gun completely, regardless of experience or environment. Beyond its battlefield use, the M2 set a standard for firearm engineering. Its recoil-operated belt-fed design became a blueprint for future heavy weapons, influencing engineers worldwide. Browning's principle, that simplicity and reliability outweigh flashy innovation, remains a cornerstone of military design philosophy. The M2 Browning did not just fight wars, it defined them, leaving a mark on history that extends far beyond the metal of its barrels and bolts. By mid-1917, John Browning had completed the first working prototypes of what would become the M2 Browning machine gun. It was a marvel of engineering, recoil-operated, air-cooled, capable of firing the enormous 50 BMG cartridge at rates of up to 600 rounds per minute, and rugged enough to endure mud, sand, and extreme temperatures. The next step was testing, and Browning's meticulous attention to detail was about to face the ultimate challenge. At Colt's laboratory in Hartford, Connecticut, the prototypes underwent relentless firing trials. Every component was examined for stress, every barrel measured for warping, and every round scrutinized for consistency. Observers from the U.S. Army Ordnance Department attended, skeptical of a civilian's ability to deliver a weapon that could meet military demands. Early tests were promising but brutal. The first prototypes fired thousands of rounds without jamming, a feat unheard of for a weapon of such caliber. Barrels heated to glowing red, metal shrank and expanded, yet the mechanism functioned flawlessly. The breakthrough came with Browning's recoil-operated design refinements. By carefully balancing the bolt, adjusting spring tensions, and perfecting the feed system, the gun could absorb the tremendous energy of the .50 caliber round without failure. For the first time, American engineers witnessed a machine gun that could sustain continuous, reliable fire while mounted on vehicles, aircraft, or fixed positions. Field trials followed. In open terrain and muddy conditions, Browning's M2 outperformed every existing heavy machine gun. Unlike the European designs, which often jammed after a few hundred rounds, the M2 continued firing with only routine barrel changes. It was both precise and terrifying, capable of hitting targets hundreds of yards away while mowing down infantry or disabling light vehicles. By late 1917, the Army began small-scale production contracts, but the true test would come on the battlefield. Though the U.S. had not yet sent large forces to Europe, the weapon was intended to prepare American troops for the intensity of modern mechanized warfare. Browning continued refining the design, even as America entered World War I in April 1917. He increased the gun's durability, strengthened the feed mechanism, and tested its versatility on different mounts, tripods, tanks, and aircraft. Each adjustment made it faster, stronger, and more reliable. The first field deployments arrived in late 1918. Though the war ended before the M2 could see large-scale combat, its potential was undeniable. Reports from training camps indicated that troops quickly mastered its operation, and instructors marveled at its ease of disassembly and maintenance. even under adverse conditions. The U.S. Army's confidence in the weapon grew rapidly. It was clear that Browning's design was no longer theoretical. The M2 was not just another machine gun. It was a weapon that could dominate future battlefields, capable of turning ordinary soldiers into formidable defenders. In the quiet of his workshop, Browning had solved the impossible problem, creating a civilian-designed heavy machine gun that combined power, speed, and reliability in a single enduring platform. The stage was now set for the M2 to prove itself on the global stage, a test that would come just a few decades later, in the fires of the Second World War. By the outbreak of World War II, the M2 Browning was no longer an experimental weapon. It was a cornerstone of Allied firepower. Mounted on tanks, jeeps, and aircraft, the .50 caliber machine gun became a symbol of unstoppable force. From the beaches of Normandy to the islands of the Pacific, it transformed the battlefield. In the skies, B-17 bombers relied on multiple M2s to protect themselves from enemy fighters. Flexible mounts allowed gunners to sweep across vast distances, their rounds tearing through aircraft and sending enemy pilots into retreat. The gun's volume of fire and accuracy gave Allied aircrews a fighting chance against swarming Luftwaffe fighters, turning the tide in countless dogfights. On land, the M2 redefined infantry tactics. Mounted on trucks or tripods, squads could cover open fields, halt armored advances, and defend strategic positions with devastating efficiency. Soldiers reported a confidence in their firepower they had never experienced before. Knowing the M2 could suppress enemy positions allowed units to maneuver aggressively. In the dense jungles of the Pacific, Marines used it to hold beachheads, its high-caliber rounds shredding fortifications and clearing paths through entrenched defenders. The M2 also proved decisive against vehicles. Lightly armored tanks, trucks, and artillery positions fell to its .50 caliber rounds, giving Allied forces the ability to control mobility and dictate engagements. It became the weapon that could level the battlefield, giving the advantage to whichever side wielded it effectively. Yet perhaps the most profound impact was psychological. The M2's unmistakable roar struck fear into enemy troops. German soldiers in Europe and Japanese forces in the Pacific came to associate its sound with certain destruction. It was not merely a weapon. It was a force multiplier, a guardian, and an enforcer rolled into a single machine. Behind this legendary firepower was a somber truth. Browning himself would never witness its full wartime impact. He passed away in 1926, years before the M2 earned its place in the annals of history. He had designed a weapon with enduring capability, one that would define American firepower for generations, yet he would see only the beginnings of its journey. As Allied forces pressed into Europe, Africa, and the Pacific, the M2 proved its worth repeatedly. In Normandy, paratroopers and armored divisions relied on it to suppress German strongpoints during critical advances. In the Pacific, jungle warfare tested every weapon to its limits, but the M2's durability allowed Marines to rely on continuous, unbroken fire. From open deserts to dense forests, from skies to shores, it was everywhere, and it performed flawlessly. Its effectiveness forced military strategists to rethink both offense and defense. Enemy tactics adapted to avoid its reach, aircraft designs were modified to withstand its fire, and armored vehicles increased their armor in response to the .50 caliber threat. Browning's creation had not just survived the test of war, it had reshaped it entirely. The decisive turning point of the M2's story was clear. A civilian-designed weapon, built in a quiet American workshop, had become a linchpin of modern warfare. It was faster than any machine gun before it, more reliable than any contemporary rival, and versatile across all theaters of combat. What had once seemed impossible, a single man designing a weapon to dominate modern battlefields, had not only been achieved, but exceeded every expectation. By the end of World War II, the M2 Browning was more than a machine gun. It was a legend, a tool of industrial and mechanical genius, and a symbol of what a single visionary could create when dedication, intelligence, and practicality converged. And the story of its creation, from a small workshop in Utah to the beaches of Normandy and the skies above Europe, would echo through history forever. With the end of World War II in 1945, the M2 Browning had already established itself as an icon of American firepower. Its 50 caliber rounds had penetrated tanks, fortified bunkers, and enemy aircraft. It had been mounted on jeeps, tanks, bombers, and naval vessels, providing overwhelming firepower across all theaters of the war. The Army and Marine Corps began conducting formal evaluations, documenting the gun's performance. Reports highlighted its unmatched reliability, even under the harshest conditions: sandstorms in North Africa, freezing winters in Europe, and tropical humidity in the Pacific. Unlike many contemporary designs, the M2 required minimal maintenance. Soldiers could disassemble, clean, and reassemble it in minutes, a crucial factor for sustaining long campaigns. Casualty reports and after-action analyses revealed another critical impact: morale. Troops who had access to the M2 felt emboldened, often advancing with confidence in situations that would have stalled units equipped with lighter or less reliable weapons. Enemy forces, conversely, quickly learned to fear the unmistakable thunderous report of the Browning. Accounts from German and Japanese soldiers described the weapon as a terror-inducing presence, one that could pin down entire squads and destroy strategic positions with frightening efficiency. Post-war, the M2 continued to evolve. During the Korean War, its effectiveness against lightly armored vehicles and fortified positions proved invaluable. Gunners mounted it on tanks and jeeps, while infantry units relied on it for long-range suppression. By the time of the Vietnam War, the gun's versatility extended to riverine operations and helicopter mounts, providing covering fire in terrain where mobility was limited. Browning's design, conceived in a quiet Utah workshop decades earlier, had endured through multiple wars without significant redesign. Attempts to replace it with newer weapons failed, primarily because the M2 balanced firepower, reliability, and simplicity in a way that modern designs struggled to match. It had become more than a machine gun. It was a standard against which all heavy weapons were measured. Even as warfare technology advanced, jet aircraft, missiles, and precision-guided munitions, the M2 remained a dependable constant. Its 50 caliber round could still pierce light armor, suppress infantry, and provide the defensive and offensive firepower necessary in both conventional and asymmetric conflicts. The weapon's enduring service became a testament not only to Browning's genius, but also to the timeless principle of designing for reliability and human usability. The aftershocks of Browning's invention were felt far beyond the battlefield. Firearms designers worldwide studied the M2, adopting its recoil-operated mechanism and belt feed system for future heavy weapons. It became a benchmark for mechanical excellence, influencing military doctrine, vehicle design, and aircraft armament strategies for decades to come. By the mid-20th century, historians and military analysts began recognizing the M2 not just as a weapon, but as a pivotal factor in U.S. military success. Its presence allowed smaller forces to hold positions against numerically superior enemies, enabled rapid offensive operations, and provided unmatched defensive capabilities. The gun was not simply a tool, it was a force multiplier, a game-changer that exemplified the impact of innovation in industrialized warfare. In every theater, deserts, jungles, mountains, and oceans, the M2 had proven itself. And though John Browning had passed away nearly 2 decades before the war, his design carried the weight of his vision, shaping the outcomes of battles and the lives of countless soldiers. The M2 Browning's influence did not end with Vietnam. Its design continued to dominate through Cold War conflicts, regional wars, and modern engagements in the Middle East. From mounted positions on Humvees to naval ships and aircraft gunner stations, it remained a versatile and dependable asset. Part of the M2's enduring success lay in its engineering simplicity. Even after decades of technological advancement, no replacement could match its combination of firepower, reliability, and ease of use. Every spring, bolt, and feed mechanism had been designed with practicality and durability in mind, ensuring that soldiers in combat could depend on it under conditions that would destroy most other weapons. Veterans of multiple conflicts recount the same theme. The M2 was a trusted companion. In deserts, jungles, and urban warfare alike, It could pin down enemies, suppress fire, and provide cover for advancing troops. Its psychological effect was as significant as its physical one. Enemies feared it, and Allied soldiers respected it as a symbol of mechanical supremacy and firepower assurance. Engineering analyses also revealed why the M2 endured. Its recoil-operated belt-fed design minimized jams, reduced wear on moving parts, and allowed for continuous fire without overheating. The air-cooled barrel, although heavy, offered the perfect balance between heat dissipation and durability. These factors ensured that the M2 could operate in conditions ranging from Arctic cold to desert heat, performing consistently where other weapons would fail. The legacy of Browning's creation also extended to its cultural and historical significance. It became a symbol of American ingenuity, proof that a civilian's vision could change warfare for decades. From military manuals to training programs, from documentaries to museums, the M2 was celebrated as a benchmark of firearms engineering. Even modern conflicts underscore its relevance. In Iraq, Afghanistan, and Syria, soldiers continue to rely on M2s to provide long-range fire, vehicle defense, and support for infantry operations. Drone technology and precision munitions may dominate headlines, but the .50 caliber round and the reliable platform Browning created continue to shape engagements in decisive ways. The M2's story is also a reminder of the human impact of innovation. Browning's meticulous design principles, simplicity, reliability, and usability, saved lives. By giving soldiers a tool they could trust implicitly, he enabled them to fight effectively, survive the chaos of battle, and execute tactics that would have been impossible with inferior weapons. Through every war and every generation, the M2 Browning has remained a mechanical constant, a bridge connecting the industrial ingenuity of the early 20th century to the warfare of the 21st. Its unmatched reliability has made it not only a weapon, but a legend, proof that thoughtful engineering can endure far beyond the lifespan of its creator. In the end, John Browning's vision had succeeded beyond imagination. From a small workshop in Utah to the deserts of North Africa, the jungles of the Pacific, and the skies above Europe, his machine gun had transcended time, becoming both a tool of war and a monument to human ingenuity. The M2 Browning was no longer merely a weapon. It was history in motion, shaping outcomes, protecting lives, and setting a standard that no other machine gun would surpass for generations. In the quiet moments after battle, the M2 Browning stands as a testament not just to firepower, but to human ingenuity. It began in a small Utah workshop, far from battlefields and military hierarchies, where a single man, John Moses Browning, sought a solution to a problem others deemed impossible. With pencil, metal, and intuition, he created a weapon capable of shaping the course of modern warfare. The M2 is more than steel and springs. It embodies principles that transcend time: simplicity, reliability, and thoughtful design. Browning understood that a weapon's true power lies not in complexity, but in the trust it inspires in those who wield it. Generations of soldiers have relied on this trust, advancing under fire, defending positions, and confronting enemies with confidence born from a machine that never faltered. Its reach has been extraordinary. From the muddy trenches of World War I tests to the beaches of Normandy, the jungles of the Pacific, the frozen hills of Korea, and the deserts of the Middle East, the M2 has endured. Conflicts change, tactics evolve, technology advances, yet the M2 remains a constant, a bridge between past and present, a living proof of engineering that anticipates the chaos of war. There is a quiet poetry in this longevity. A civilian's vision became a battlefield legend. The roar of its .50 caliber rounds is not merely a sound of destruction, but the echo of one man's dedication to perfection, one man's understanding of both the machine and the human who must rely on it. In the end, the story of the M2 Browning reminds us that true innovation is not flashy or transient. It is steadfast. It endures. It shapes the world long after its creator has gone. And in the case of John Browning, it is a legacy that continues to protect, define, and command respect. A machine gun that is, in every sense, timeless.